Newton's first law is also known as the law of inertia. Now, Newton's first law states that an object at rest stays at rest and an object in motion stays in motion unless acted upon by an unbalanced force. Now, that's a mouthful, so let's unpack it for a second. So the first part is an object at rest stays at rest and an object in motion stays in motion. Now, this is the reason that Newton's first law is called the law of inertia. We know that inertia is the resistance an object has to a change in its motion. So an object at rest is going to stay at rest, or an object in motion is going to stay in motion. They have a resistance to a change in their motion, okay? So if an object is staying at rest or staying in motion, now this state object at rest, that just means that the velocity is zero, right? That object is at rest. Now, an object in motion that's staying in motion, what we mean here is that that object is staying in motion at constant speed in the same direction, so at a constant velocity. Now, if an object has a velocity of zero or has a constant velocity, what this means is that there are just no changes in velocity. So because there are no changes in velocity, there's no acceleration. Now, the second part of Newton's first law says that the object is going to remain in motion or remain at rest unless acted upon by an unbalanced force. So, what is an unbalanced force anyway? Now, a balanced force looks something like this. If there's a physics book sitting on a table, we know that the force of gravity keeps that physics book on the earth, and then the force of the table is keeping that physics book upright. If the force of the table wasn't there, the physics book would fall to the ground. There are things called free body diagrams that we use in physics in order to draw our forces. Now, here's two examples of free body diagrams that have all balanced forces. Notice how the first one, we have 30 newtons to the left, 30 newtons to the right. Those are balanced because they're the same magnitude but in opposite directions. And then we also have 50 newtons up, 50 newtons down. Again, those are balanced forces. So a lot of students say, oh, those forces cancel out. And yes, that is kind of a way to describe balanced forces. Now, what if instead we had a physics book sitting on the table and we gave it a push and an applied force? Right? This is an unbalanced force. Because this unbalanced force doesn't have a force to kind of counter it, we have an unbalanced force, and that object is going to change its motion. We know if we push this physics book, it's going to not be at rest anymore. It's going to start moving. Now, what if you pushed that physics book and then after you gave it that push, it's now sliding to a stop? Now, the reason that that physics book doesn't continue its motion like Galileo said that it might is because we have another unbalanced force called friction causing this physics book to stop sliding. All right, so these are unbalanced forces that are causing the change in the motion here. So again, Newton's first law states an object in motion stays in motion and an object at rest stays at rest unless acted upon by an unbalanced force. This second part here, unless acted upon by an unbalanced force, basically means that if an unbalanced force acts on an object, its state of motion changes. So I gave the examples of pushing a physics book. You are changing that state of motion, which was rest, and you are causing the physics book to move. Or if the physics book is already moving and then slides to a stop, again, that unbalanced force of friction is causing that state of motion to change. It's causing the physics book to stop sliding. Okay, so because the state of motion is changing, the velocity is changing, which means that there is an acceleration. So the main point here is that unbalanced forces are what cause accelerations. If we have no unbalanced forces, then there is going to be no acceleration.